Today on How It's Made. Garden forks. We dig up all the facts on this common or garden tool. English toffee. Sugary, sweet and chewy. You'll love to get your teeth into this report. Paint chip cards. We'll be honest with you, it's a bit like watching paint dry. And Bundt pans. Have your cake and eat it in a number of decorative styles. But first, the humble garden fork, once a highly prized possession, so sought after it was often the subject of theft. That was a long time ago, when survival depended on the food people grew. Today, of course, food is mass-produced and sold in supermarkets, but the garden fork is still at the top of your garden tool table. There are many versions of the garden fork, from hand forks to border forks. There's one for every job. At this factory, they've been forging garden forks for over 200 years. Using a 600-ton punch press, 2 basic fork shapes are cut out from this hot and malleable steel. The tines or prongs for this particular kind of fork are shorter than most, because these are border forks, used for turning the soil rather than digging deep. With the basic shape now established, it's back into the furnace to re-soften the stem. A worker repeatedly feeds it through rollers to thin it down and widen it. This press then trims it, at the same time cutting holes for attaching the wood shaft. The next press drives the steel stem into a cylindrical die, forcing it into the basic shape of a socket. The worker slides the socket into a cone form and strikes it repeatedly to refine the socket. This sizes it for a wooden shaft. It's a completely different process when making digging forks, because of their longer curved tines. After forging a spider shape, a worker bends a prong around a post to position it for shaping. This 2-person team works in tandem. One fires the spider and bends the prongs. The other inserts the prong into the grooves of 2 revolving dies to stretch them. With 2 tines now shaped, his partner bends them out of the way so he can work on the third one. Rolling takes 18 months of training to perfect. If the tine isn't precisely aligned with the grooves, the equipment could seize, causing possible injury to the worker, and the dies would almost certainly be damaged. With the 4th tine now stretched, the other member of the team twists all 4 tines around the post again, this time to bend them all in the same general direction. After about 10 minutes of work, they have the rough shape of a digging fork. They then form the socket and crop the tines. Fired to a malleable state again, a worker drives tooling between the tines to straighten them and even the gaps between them. He rests the fork socket against a steel slope and lowers a ram. It drives into the tines, pushing the socket against the slope, bending it upward, which gives a better angle for digging. He inserts the tines into a press, and the press closes around each tine to taper the corners. A ram now pounds the base of the tines against a swooped anvil to give it a gentle curve. The hot fork then goes into cool water, which serves to harden the steel. The next worker grinds off any rough from the sides and sharpens the edges. He narrows the tips to a point, and this will enable the fork to pierce solid earth. Any minor adjustments are made manually. Here you can see the difference this makes. The prongs on the left are out of alignment. The ones on the right have been fixed. An electrostatic charge is applied to the forks to attract a green powder spray. Once cured, it forms a skin that resists corrosion. Now out of the curing oven, the fork is locked in place while a wooden shaft is put into the socket. It's secured with rivets. A belt sander is then used to blend the wood to the metal in a process known as linishing. The bottom fork is the one that's been linished. Finally, the wood shaft and handle are dipped in varnish, giving them a glossy stain that enhances the grain. This garden fork is now done, but it won't look shiny and new for long, because it'll be digging the dirt very soon. Toffee is a confection traditionally made of caramelised sugar or molasses and butter. There are many different varieties, soft and chewy or hard and brittle. English toffee is very buttery and typically covered in nuts. Easy to see why it's called English toffee. This English toffee is completely free from dairy ingredients, making it ideal for toffee lovers with certain dietary requirements. This small confectioner makes their special toffee recipe entirely by hand, one small batch at a time. They start by combining water and sugar, which they heat until the sugar dissolves. They add their own secret formula. All they'll tell us is that it contains a combination of vegetable oils and fats, which are the non-dairy substitutes, and beta-carotene to give the toffee that familiar golden colour. They add an emulsifier called lecithin to stabilise all of these ingredients. As soon as the mixture reaches the boiling point, they add salt to enhance the flavour and help force a rapid boil. The boil continues for several hours until the mixture hits a top-secret target temperature. By that point, most of the water has evaporated, leaving a sweet and thick liquid toffee. Now they open a hot water valve, which releases water to heat up a table. Then carefully pour the toffee onto the surface. The heat ensures that the toffee is pliable while it's spread out. The spreading continues until the toffee sheet is approximately the same thickness. Naturally, the thickness varies, but that lack of uniformity is all part of the charm of handmade toffee. They take a tool with multiple cutting discs and run it over the toffee sheet in one direction, then in the other. They close the hot water valve and open the cold water one, which cools the surface of the table and hardens what are now toffee squares. Within a few minutes, the squares are hard enough to be broken apart. Now 2 additions, which will turn this into English toffee. Firstly, semi-sweet chocolate. Once this tempering machine heats it to the right consistency, a pump feeds it to a machine, which coats the toffee squares in 2 stages. With the underside now coated, the squares move onto a refrigerated belt, which rapidly hardens the chocolate. The next station covers the other side with chocolate. As the now fully coated squares exit the machine, the belt vibrates, shaking off the excess chocolate. The squares move onto another refrigerated belt, and a worker manually sprinkles them with the second ingredient, chopped pecans. The squares travel through a cooling tunnel for several minutes to set. As they reach the end of the line, excess nuts drop off and they're collected, ready to be sprinkled onto new squares. Some English toffee recipes call for almonds rather than pecans, but the idea is the same. Layering sweet and crunchy toffee, smooth and creamy chocolate, and coarsely chopped nuts. And just like other sweets and treats, English toffee is heaven to anyone with a sweet tooth. But hell, of course, for their dentist. Open wide. Coming up. Alas, it's not the cake factory, but the factory where the cake tins are made. We're on the hunt for Bundt pans. And if you've ever decorated a room, you'll know all about this colourful company. They help you choose the colour scheme. We see how swatches are made. Join us after the break. Trying to decide on a paint scheme? Each card is a small sample of related shades, allowing you to view the actual hues without prying off the lids of cans in paint shops. With thousands of shades to select, you'll be in the pink, or any other colour you choose for that matter. Whether you're looking for a gorgeous green or an OMG orange, careful scrutiny of paint chip cards can help you get it right before you pick up a brush. Highly concentrated colorants stored in tanks will be used to reproduce paint colours in lacquer, similar to the kind used in nail polish. Lacquer is used because it produces better results on paper than actual paint. The colorants are piped into a nozzle dispenser. At the same time, a bucket containing the lacquer moves to meet it. The dispenser has many tentacles, and each one is connected to one of the colorant tanks. A computerized mechanism holds the nozzles to dispense different colorants, following a precise color formula. The bucket sits on a scale, and the weight is constantly monitored by the computer to confirm that the exact amounts are being added. A blender mixes the colorants in the lacquer. The mixing speed and time have been preset to avoid over or under mixing. Now for the color test. A technician spreads the sample evenly across a piece of paper. A convection oven then dries the color. The technician compares the color and gloss to that of the standard. He also does a computer analysis and sends the formula back for tweaking where necessary. This worker pours the approved lacquer-based paints into cylindrical tanks above the coating machine. There are over 24 of these tanks because they'll be putting that many colours on the swatch in one production run. He connects plastic tubing to the tanks to narrow the flow and aim it at the dye block below. Lacquer flows into a dye, coating the paper with an endless rainbow of colour. A bar overhead spreads the lacquer evenly without actually touching the paper. The paper then travels through an oven and the solvents evaporate, leaving a dried lacquer skin on the paper. If regular paint had been used, the paper would have absorbed it and ended up wavy. Rotary blades cut the coated paper into sheets, sized to fit printing machinery down the line. Using a transparent template, the next worker measures the width of each stripe. He then confirms that the colours are in the correct order by checking each stripe against the approved proofs. He checks the gloss with a gloss meter. It works by aiming a light on an angle and then registering the reflection. This confirms that the gloss is consistent and the production run can go ahead. The press operator stacks them face down for loading into the printer. A feeder serves up the striped sheets to the printing line, one at a time. It's a 4-station printing press. Each cylinder is equipped with an ink of a different colour to stand out against the various paint card stripes. They print the paint colour names and numbers on both sides. They also apply varnish to the back of the sheets, so the paint chip cards won't stick to one another when they're stacked. Named and numbered, the colour stripes are now all identifiable. The sheets go under a guillotine blade, which slices them into paint chip cards. Powered by hydraulics and super sharp, the blades cut through hundreds of paper sheets like butter. They produce 3.5 million paint chip cards a day at this factory. So if you can't think of a colour for your bathroom or your bedroom, just pop down to the paint shop and get them to lay their cards on the table. A Bundt pan is for baking a dense ring-shaped cake called, oddly enough, a Bundt. Typically it has a fluted or swirled design and originated in Europe. The name is thought to come from the German word Bundtkuchen, Kuchen meaning cake and Bundt meaning a gathering of people. Nice. Bundt pans were originally ceramic, which is fragile, or cast iron, which is heavy. Today's version is typically made of cast aluminium, unbreakable and much lighter. At the factory, they begin the production process by melting ingots of recycled aluminium. The furnace heats the ingots to 700 degrees Celsius, at which point they liquefy. From the melting furnace, workers transfer the molten aluminium to a holding furnace, which keeps it in a liquid state until casting. The casting process is entirely automated. A ladle descends into the holding furnace and scoops up just under 1 kilogram of aluminium, enough for one Bundt pan. The molten metal then gets poured into a sleeve. A high-speed ram immediately pushes it into a Bundt pan mould. The pressure and speed combined shoot the molten aluminium into every part of the mould cavity. As the hot aluminium hits the cooler mould, it solidifies in about 10 seconds. Then the two halves of the mould automatically separate and the cast pan is extracted. Between castings, a robot cleans the mould with a blast of air, water and lubricant. This removes any residue. This is critical because even a tiny speck of dust left behind would mar the next casting. As each pan comes off the machine, workers inspect it for any flaws. When it comes time to produce a different style Bundt pan, like this one with 6 mini cake forms, they simply mount the corresponding mould onto the casting machine. Because the machine fills the mould under pressure, some aluminium oozes out between the two halves of the mould, and that's removed with a single strike of a trimming press. A computer-guided router, working 2 pans at a time, smooths the rough edges. Then it refines the handle slots, finalising the shape. Now the aluminium surface must be spotless, ready for a non-stick coating to be applied. So the pans go through an industrial washing machine. 1 wash and 3 rinse cycles, and finally, a drying cycle. The pans now move down the coating line. As the pans spin by, spray guns apply a silicon-based decorative coating to the outside surface. The pans then go through an oven for 15 minutes to cure the coating. The pans are then flipped right side up and sent through another spray line, this time to coat the inside. The interior coating is a food-safe silicon polyester material, designed to release the cake easily from the pan. It's similar to the non-stick coating on a frying pan, the difference being that the chemical composition is designed to prevent sugar rather than protein from sticking to the pan. Once more, the pans go through an oven for 15 minutes to cure the coating. Once the finished pans exit the oven, they're inspected for any flaws in the coatings. From a practical perspective, a Bundt pan's ring shape has definite advantages over an ordinary pan. The tube in the middle funnels heat to the centre of the cake mix, helping it bake quicker and more thoroughly. So next time you want to impress your friends with your cake baking skills, you may want to take a punt on a Bundt. I thank you.